Hello, CoinGeek. Hello, Genesis. Finally, I think I'm probably one of the most excited people around the world who's passionate about Genesis, because without Genesis, the business I'm building on simply cannot work. It's life or death issue. So for people who don't know, so sCrypt is we are a company that provides integrated on-chain smart contract solutions. So our flagship product is a so-called sCrypt. It's a high-level language that is syntax-wise very similar to JavaScript or Solidity. So it can help developers to write easily smart contracts native on Bitcoin. So I made some presentation at CoinGeek Seoul. So today I'm going to very excited to report on a lot of progress we have been made in the past 4 months or so. So first, of course, we have I'm happy to release the sCrypt language 0.1. So there are a lot of features. I think without going too much into details. So here, number one, we see here is so-called one of my favorites. It's basically, it allows you to reuse other contracts through the so-called import syntax. So here I show a very primitive example here. So basically, this contract basically shows whenever you send Bitcoins, that's what happens on the script level. So basically, it's a so-called pay-to-public key hash contract. So what it does is first, it takes the public key, it hashes and compare, it makes sure the hash matches whatever the address represents. And after that, you can take the public key and the signature, and you verify the signature. So basically, you can kind of break it into 2 parts, and the left is dependency, then you can import it. And second, now we have the dependency, now we can import. Of course, we talk about a lot of language, the typical way to wrap it around in the standard library. So developers, they don't have to write manually. For example, here, I also have the P2PKH contract as a standard library, so you can just one line do it, and then you can use it in your code, just one line. So for now, can we go to can we switch the screen, please? Thanks. So I'm super excited today to announce our first release of our desktop IDE called sCrypt. You can go to Visual Studio Code if you use it, which is one of the most popular IDE in the world. So you can go to the marketplace, you can search sCrypt, and then it will show up. That's our fully implemented IDE here. So basically, you can see that they have a lot of features around here. And also, I'm going to do a lot of walkthrough about how it works. It's basically trying to make the experience as similar as to develop any kind of a non-Bitcoin applications. It's like a JavaScript. So for example, if you can go to some, let's, for example, see some contracts here. So here I have a contract. Now I want to see, OK, first of all, of course, you can notice the syntax is highlighted, right, like any other kind of language. And then you can, for example, if I start typing, say, let's start a number, maybe, let's say, OK. So if I start typing, you can see it's instantly give me auto completion. For example, I can choose from this functions or this property. So let's say I choose this. So basically, this is a function I can call. OK. Now it also prompts as I type. You can show, OK, so what is the parameters for this function? See, you can see the prompts around here too. So also, if you can notice, if I say, let's say, make some mistakes intentionally, and it will also mark, oh, OK, you are missing an equal sign here. So, and also, for example, I can say delete the type here. It also shows, oh, OK, now it's not defined. So basically, it tries to give you the same experience as you develop for any non-Bitcoin or blockchain applications, like in JavaScript. So another thing I want to show is if you say, of course, you want to see the interaction, right? So let's say I go to another contract. You can easily click on the right, and then you can say, oh, compiled. Okay, then you can show you instantly whether this passed it through, and it's that easy. And also, let's say if you say you accidentally or you didn't create some format, okay, so you can say, okay, select this, and say, format the selection, and then boom, it comes formatted. You can format the selections, and also you can choose to format all the document as a whole. So can we go switch back? So this is to get you a sense about the ID. Basically, it lets you to write any kind of mimics the experience of developing any other high-level language. And also, one piece we cannot miss is testing part, right? So especially we are trying to deal with real money here. You don't want to lock some funds which you cannot recover later, right? This is a great risk. So security is of paramount importance here. So for that, we have the testing framework here too. Can we now also go back to the screen again for the demo, please? So again here, I show one example. So let's say I have the contract here. Basically, what it does is, so basically take two numbers, x, y, and then the way you log it is through you provide the sum. So on the right side, I can show the test. So basically, it's very easy. So it's one line. So basically, we have the SDK called sCrypt test. Once you import that, you can say one line. You can say, oh, build me this contract class. So basically, it now lets you to play with this contract, which is demo, as if it's a JavaScript class. So you can initialize it. Let's say demo. You give it two parameters, 4 and 7, and then you can call the function it has. So unlock here, as I mentioned, is basically you only succeed when the input you put is the sum of the two. So in this case, okay, it will pass, right? So for example, you can also run it very quickly by right-click and then say run test. Okay, now it's running, and boom, now it's good, right? So basically that lets you to test the sCrypt pretty much in JavaScript. Can we go back again? And the next question is, now you have the high-level language, and also you have the developing tools. What can you do with it? That's the number one question. So I'll give a few test cases, use cases here, hopefully to give you a sense. Actually, a lot of things can be built on top of this. It's actually very powerful, much more powerful than at least what I expected. For example, here, I show one example. So basically, this contract lets you to access the transaction that this contract is within. So this is, previously, this is almost considered as impossible to do because when you look at the script opcode, there's no off-push transaction. So basically, you cannot. So how do you do it? It's actually a very nice technique. So first, you push the current transaction onto the stack, and then you give it you signed with some private key. But don't worry too much about it. This private key is just to show this transaction is what you have, the current transaction. It doesn't affect. It's any kind of private key is fine. So after you have the private key, then you do the so-called ECDCA. Basically, you do the digital signature within script. So thanks to the Genesis, now we can finally do it within script itself. We don't have to rely on external computations. So then, after you have the signature, you push on the public key, and then you can do the so-called check signature. So if it checks, that means this transaction you pushed in is exactly the current transaction. So also you can follow a little bit of the code. You can kind of get a sense now it's doing whatever we showed above. So can we switch back again? Okay, thanks. So I give one example here. This is that's enough. I mean, sCrypt code, so it's better to see whether it works in reality, right? So that's why I construct some transaction, which you can see is not the usual script you usually see. It's basically, it compiles pretty big. You can see around I think Daniel Connolly showed earlier. So basically, this is what he showed. I'm showing earlier I showed the source code, but now this is the script. You can see it's, I don't know about you, but I deal with sCrypt, but I would rather not to program this in script directly. Maybe you can code it, but it's just, I feel it's more convenient to use sCrypt. Okay, can we go back again? All right, so here is another very good trick I like. So for people who know the opcode, that's one good opcode the core developers add is the check log time verify. So basically what it does, you send some money to address, right? So usually when you send to address, then the receiver can spend it immediately. But here, basically it puts a log into the output, into the so-called UTXO, not the nlog transaction. So basically how you do it, so previously I showed the trick. You can get the current transaction, right? So once you have the access context, basically it gives you the transaction, and then you can pass it. You can get the nlog time out of it, and then at the lastly, you check the nlog time is greater or equal to the number, the mature time you specified. So also like Daniel Connolly, this is the original source code. Okay, so this basically makes sure it cannot be spent before the mature time. Okay. So I just give only a few examples, and this is actually unbounded, as my title says. You can also do a lot of other things. Let's say layer 1 tokens, because now you can have the transaction. You can put limits on arbitrary conditions on the output, on the inputs. So one thing you can do is the minor enforced tokens. And also, you can say, instead of log to nlog time, you can only spend after certain time. You can say, oh, you can only spend between this month and next month. You can say any kind of any arbitrary timing condition. Also, you can talk about split payment. Basically, you log some payment. If A gets eight satoshis, then B also get 2 satoshis. Basically, you can split and depends on other kind of contract. And also peer-to-peer gaming and PSO as well. All right, that's the end of it. I would like to thank my collaborator here, Yichang, for helping me with basically he pretty much do the whole work for the IDE, so I just show it. And Stas, which is sitting here, for a lot of advanced sCrypt usages. And you can find us on here, on the links. And let's build a smart contract on BSV. Thank you.
Hi, it's Hannah for CoinGeek.com, and I'm here with Xiaohui Liu from sCrypt. Lovely to have you here.
Nice to be here.
Now, you have just announced something very exciting in London today. Tell me all about it.
sCrypt, we're a company that are trying to have smart contract solutions on top of Bitcoin SV. So we just released the first ever IDE that can let developers write smart contracts very easily. It's like a JavaScript to write easily native contract on top of Bitcoin SV. So basically, you can think of is almost like you're trying to unbound, to remove all the caps. That's why I'm super passionate about the Genesis, because before Genesis, all this smart contract, they are intentionally crippled because of the limits. Now we have Genesis. We remove all the artificial limits, so finally we can use this sCrypt tool to write very complex smart contract. It's like JavaScript or Python. Now you have the tool, you have the IDE, then you can build unlimited things. So I would definitely love to have all the developers check into sCrypt and use the IDE. Very excited to see what people build with it. Yeah.
I mean, that's really exciting to hear, and I can see how happy you are about it. So how does it feel to, like do all of that work and behind the scenes, and then you're here announcing it? How do you feel right now?
Yeah, it's kind of like you've been working for a year now, so it's mostly behind the doors, behind the scenes. I try to have some people to test it out, but it's almost like your baby. It's like you are showing it to the real world and in front of the biggest crowd ever. So I've been to CoinGeek since the first one in Hong Kong, so I can definitely see the crowds that are growing. So it feels unreal. It is from attending CoinGeek to seeing other people on stage to be invited. It's surreal.
Well, congratulations on your business and, of course, your baby.
Okay, all right, thank you.